All right, let me share my screen, and we are going to jump into the platform itself. So as we said, right, DataRobot has several components. I'm not going to do a full-blown everything. I'm actually focusing on the AutoML part, and then a little bit the deployment part. As I said, right, the deployment is almost the most important thing in the end, getting those machine learning models up and running. But we need to start somewhere. So let's start with some data and an actual problem. And my son just is coming visiting me, so I apologize if there's any noises in the background. He's 2 years old. Right, so I have some data here. Basically, this is data from a website where you can buy a house, right? You can. So we have different listings of properties on this website of kind of houses that are for sale. And it would be great, right, if based on this information, of all of this historic information that we got from this this website, if we could predict the value of any property that is currently being sold. So we see a lot of many rows in this data set, the price of the property, of course, but also other explaining factors like how many bathrooms are there, maybe some kind of explanation about the amenities, right? Is there cable TV available, etc., etc. The square footage, and when was it sold? Now, this is not all of the information we have. We also have information about the history. So for each elementary, this is kind of a district of the city we're talking here. For each elementary, we actually have a history going back many decades about the kind of price per square footage that we saw there, and the historical prices. So maybe that helps us getting better predictions. We also have some information that we just downloaded from the internet, which is, it looks a bit weird. It's geospatial information. So this is each zip code or Postleitzahl, right, in German, has kind of the region it covers. So this is just a description of that in a kind of common language that people use. You can download it like this from the internet. We also have information about the images, right? Each property comes with an image, and we see here these are the different properties that are for sale. So I want to now use all of this information in order to predict the price of each property. So where do we start? We actually start by getting the data in. You can connect to some database. You can upload them from your computer. I can also use the AI catalog, which is kind of a landing zone for data sets where I can put them. And I've uploaded them already in the past. Here they are. This is the primary data set with the house price information. So I'm going to create a new project with that. Now, every time you do create a new project, you actually find that we look at every single column of data, right, and try to find out what's in there. Is it numeric? Is it a picture? Is it a date? Is it text information, right? All of this is being looked at in order to make use of this information in the best possible way. Right, uploading takes a few seconds, but then we're there, and we see now the information, basically the same information as we just saw in the Excel spreadsheet. Now, of course, this is only the one data set, so I need to add all of the other ones as well. But before, I need to tell DataRobot what I actually want to predict. In our case, it's the price of the house. And we see it's a regression problem. Now, I did talk about various other use cases that we've done in the past, right? These would also be different families of machine learning problems, right? Sometimes we want to predict something like a price, so a continuous target. Sometimes we want to predict some categorical information, right? Is my customer going to churn, yes or no? Sometimes we want to predict something over time, like in the demand forecasting case. And sometimes we just want to do anomaly detection, where we would say no target. We just want to find out what's in there, right? So maybe clustering, maybe anomaly detection. So now I want to bring in my secondary data sets. So I hit that button, and first I'm going to be asked, well, what's the prediction point, right? And I'm going to say, well, the sold date, that's the cutoff point. If I join any additional information to this data set, I want to make sure I only join things out of the past and not out of the future accidentally, right? That would not be great, because of course I only know the past. So now I'm going to say, I want to add some data sets, which I also uploaded already. And we're going to take our images, we're going to take our historic information, and we're going to take the geospatial information. And after this is done, I can continue here. So the next step is now I have to tell the robot, well, how do these data sets belong together? This is one of the last things we have not yet automated. So I'm going to say the images belong to the data set, to the primary data set. It's a one-to-one relationship. Each listing has one image. That is very simple. Same is true for our geospatial information. Each property has exactly one of these. It's a little bit more interesting with the historic information, because here we actually have several observations per each listing, because our house could have been sold some point in 1980, 1990, etc., etc. So we are joining on the district, and then we're saying, actually, there's a time information here as well, the year in which the history now relates to. We actually want to go back only a certain number of years. I don't want to go back too far, because then it's not relevant anymore. I can change this if I wanted to, but I'm happy with 30 years of history. So with that all out of the way, I now have my relationship. In this case, it's fairly simple. This can be, of course, much more complex, and I'm going to continue to my project. And now the last thing really to do is to hit that big start button. Now, one thing I need to notice, DataRobot is, it tries to automate as much as possible, but it still wants to give you the opportunity to look behind the scenes, make sure that everything that is preset makes sense, and then if not, change it as well, right? This is something we want to do. There's years of best practice, and hundreds of the best data scientists in the world worked on this platform. So yeah, I would say, yeah, 90 out of 100 cases, you can just click it. If not, you can check the advanced options, see what we're actually doing behind the scene, how we split the data, make sure we only train on some data and validate on an unseen part of the data. There's a few other options that we can set. I'm not going to too much detail here. I'm just going to hit the start button. So after we do that, now the actual work begins, right? So we now need to look at not only this one data set, but the 4 data sets that we specified. We will create new features, new kind of describing factors out of those secondary data sets as well. They're being joined here, and we see these things like selecting features, generating features. And these are tasks that, if you would do this manually, you would have to do anyway, right? You would do pretty much the same thing as the robot is doing, only that it takes you a lot more time and it's very repetitive, right? So nothing is stopping us from actually bringing our own feature engineering into this process. If we know already, much better, can be. But we are taking away a lot of the more repetitive tasks that you would do anyway. After that, there's a kind of more interesting point, which is the generating of blueprints. A blueprint in DataRobot is kind of the actual machine learning algorithm. It consists of various pre-processing steps. So the data, right? We see the data has some quality issues here. There's maybe outliers that we detected, maybe some missing values. So all of this needs to be dealt with somehow. Again, quite repetitive tasks. So what we do is we just do it anyway, right? You don't have to care about that too much. And the blueprints will deal with that. And then on top of that, we actually look at the different machine learning algorithms that you have available. We include a lot of open source machine learning algorithms. We have some of our own proprietary ones. But in the end, you can rely on our experience, right? Hundreds of data scientists doing this for many years, almost 10 years. And you don't have to worry about some of these details so much, like which hyperparameter for which exact machine learning model is the best. That's typically not the most interesting question. The most interesting question is more, well, how do I translate the business problem that the business comes to me into a data problem, and then how do I interpret the results, right? So this is typically the shift that we see when people start to use AutoML, regardless of DataRobot, by the way. You shift more towards the problem statement, and thinking about, well, what does actually, what makes sense to ask, right, of the data, and spend more time there rather than spending time on testing, you know, oh, what happens if I put this image data in here as well, and how exactly do I do this? Right, so this is going to run a little bit. I'm skipping ahead to a project which is already complete. It's exactly on the same data. We see many more features have been created here. A lot of these, like the geo information, I can now look at on a map if I wanted to, right? So if I open this up, I see these little dots. And if I scroll here, we see this is Salt Lake City. And this is where our properties are located. We also see that the image features have been wrapped in, right? So we did the join, and our images are here, so we can have a look at those. You know, the cheaper properties up to the more expensive ones. It makes sense, right? Visually, it already makes sense. And we see how the history has been dealt with as well, right? So now we see this price per square footage. We now look at maybe a 5-year average, maybe a 30-year average, etc., etc. And then on the machine learning side, we run not only one, but many, many models. In this case, 82 different machine learning approaches on this data set. Try them all out, validate them on unseen data to find out which worked best. And then I have a contender, right? This is the best model for this particular data set out of the ones that we tried. And I can now go and have a deeper look into this. From here on, I actually have two options. Either I say, happy days, I'm happy with that. I trust the robot. So I just go and deploy it, right? And start making predictions. But in many cases, right, we want to build the trust. We want to understand a little bit more what is actually going on behind the scenes. How accurate is it really? So for that, we have a few things to our disposal here. Firstly, looking at this, we now see the nitty-gritty details of what is happening behind the scenes. If you really want to go into how images are being transformed, how the geodata is being used, all of these different bits and pieces that are happening here, and every single thing is further documented. So if you really want to know more about a specific part, you can actually look this up in the documentation. And these can even be edited, right? So I can change this if I wanted to. But typically, more importantly, right, we want to maybe look at some residual analysis, right? How accurate are our models? We want these to be on a straight line. Looks pretty good to me. Maybe we want to look at, you know, we know the map information. So can we maybe find out where on a map my model is more or less accurate, right? So here I'm under predicting, here I'm over predicting. So this could be interesting information. But then moving on, we can then find out as well what were the main driving features of each prediction. So as they say in the industry, I'm actually not part of this industry, but as they say, location is everything. And we see exactly that, right? The geometry, which is our geo information, is the strongest feature here. The strongest impact is where the house is located. Makes sense. And then things like how big is the property, the house itself. The image is also quite valuable here. And we see the amenities coming up as well. This was free text information. So how did we deal with that? Well, let me go into the insights to show you quickly that. Takes a second. There we go. We see now this word cloud, right? So whenever you see things like gated, right? Gated community, a tennis court, that seems to drive prediction higher than you know, something like the windows. Apparently, like a double pane window, it doesn't seem to be the strongest feature, right? For a property in Utah, at least. Right, moving on. We talk a lot about pattern finding, right? Finding the patterns that actually drive our predictions. And again, we can look at that. So we saw, for example, things that are important, you know, the acres or the square footage, but we can also make sense of them, right? We can see, well, with lower square footage, the property price is, of course, lower than with higher square footage, but there are indeed some regions where nothing changes a lot. So this could be interesting information for me if I was on the property market. Maybe I want to be here, right? If I'm selling my house. So yeah, just to get a little bit extra out of my property. And each individual property, so let's say I want to sell my house, I can actually get an explanation of why my prediction was so high or so low. So if I look at this, we see some of these predictions are very high, like in the millions, some of them are very low. The explaining factors are now presented here, right? So the property size, the location, how many bathrooms, like 11 bathrooms, sure. Who needs that many? Anyway, that's 29 million. So yeah, we can look at a lot of these things, right? Just to build trust in our predictions that the model made, so that we really firstly understand as the modeler, all right, does that make sense? Does that correlate with my own assumptions? But also to then communicate that to my stakeholders, right? Well, like if I'm using images, where does the model actually look at? So the last thing I want to very quickly show you is how to actually get this model now into a state where I can make predictions. And hopefully I can make this automatically. The way this would work is we say, deploy my model and set up a new deployment. So what happens now is this model is going into a dedicated prediction environment where basically I can now start making predictions from, right? So this is happening now. And if I go to my, basically on this one here, we don't really see that much, but because I have just deployed it. But if I look at my overview here, this is now the MLOps part of it. I see all of my models that are already deployed. I can have a look at, you know, the performance of my model over time. Everything is monitored, how many predictions are being made, what's the accuracy look like over time, et cetera, right? So everything is tracked, but the nice thing is, so there we go, the accuracy is tracked as well, right? The nice thing is, if I now want to make predictions, I can, oops, this is an external model. Let me go to one which is not external. Oh, maybe this one here. If I want to make predictions from this, I actually have now options to say, maybe I have a cloud database and I want to go into this database or maybe onto an S3 bucket or so, define a connection to one of my databases, and every day pull the latest data out of this database, push the predictions back to my specified location, run this automatically every day, every week, every month, and get my predictions like that. But I can also, of course, use an API, right, REST API, to get real-time predictions, for example. So all of this is available. Of course, we can also retrain those models, right? If our accuracy drops, we can trigger that the predictions are being made again, the models are being refreshed, and all of that. So this is, I think, a very brief overview of the MLOps side of things. But this is indeed where I do believe any kind of healthy machine learning lifecycle management needs to get to, right? To a place where models can be in production and you don't have to look at them every day. They are just continuing to run, there's monitoring in place. And I know I've done this in the past without DataRobot, and it took us probably a month to build the model, and then I think 3 months to build all of the monitoring around it. So we can save a lot of time here, basically, is what I'm saying. So with that, I am running out of time. I'm already over the time, so I will close it here. But of course, I'm happy to take any questions afterwards.
Definitely, and this is what we're gonna also share in the last slide. You can test DataRobot. You can do a free trial with our data, and then if you want to go a bit deeper, and this is really something which can or will impact your business, which it certainly will, then we can also discuss, you know, of course, a specific price that hopefully works for you, but also, you know, testing it out with a pilot or what we call a proof of value in the meantime. But yeah, really important to understand, we're not just going to throw a platform at you and then leave you alone. It's a very versatile platform. You can do a lot of things with it. And that's also where we have a DataRobot University. We have tons of documentation. We have a very active community, and it's always, you know, a platform is one thing, but you always have to put a little bit of effort in and learn it, and have, of course, the documentation and the learning path ready in order to make most of it. So that's extremely important for us to support along the way.